talking about React Server components. Yes. Why should you care about that? So with JavaScript, there's obviously a lot of things changing, and now we have this completely new way to build React apps. React Server components will allow us to fade the boundary between the server and the client to create rich user interfaces with minimal client-side code while still maintaining interactivity and performance. So my goal today is going to be to introduce and motivate and provide resources about RSC. So before I start, let me introduce myself. My name is Aurora. I'm from Norway, and I work as a consultant at Inmeta in Oslo. I'm a full-stack dev, but I work mostly on web these days, and I'm actively building with React Server components in my current consultancy project. And I bring to you today my view as a developer joining the cutting-edge web world and how I'm learning and working with modern technology. So the talking points of today will be first, rendering strategies. Then we'll get to React Server components, what they are, how they work, the benefits and the drawbacks. Then we'll go through the Next.js app router, onto best practices and patterns when using RSC in Next.js. And then afterwards, I'm going to show you some examples of RSC in a demo app that I've made. And finally, give my thoughts on working with RSC in a real project, as well as the future of React Server components. So let's begin with rendering strategies. You can't really have a web talk without mentioning them. It's a crucial prerequisite. So I'm not going to mention every type of rendering strategy and the history of the web here, but I'm going to go through some relevant topics. And this probably might be familiar to a lot of you. So static website rendering is the most basic rendering pattern where all pages are assembled beforehand and uploaded as static files to a storage bucket. It can be built with plain HTML and CSS or combined with JavaScript. And it's delivered exactly the way it's stored, meaning nothing will change unless the code is changed. And although quite simple and efficient, it doesn't handle dynamic data well or interactive websites, and it's quite impractical to maintain. Use case could be an informational website for a business. And you could say that this is the old way of making websites, and it's not used very much anymore. Multi-page applications, on the other hand, can handle dynamic data. In MPAs, HTML and data is merged on the server per request and then sent as one package to the client. The user will open the browser and then serve the merged result. And the entire page reloads per request or navigation to a new page. They can be created, for example, with the ASP.NET MVC pattern or with PHP, Ruby on Rails. Use cases would typically be an e-commerce app, for example, Amazon as an MPA. So what are the pros of MPAs? Firstly, all the page content can be read and indexed by search engines because it's rendered HTML, allowing them to appear in search results and be optimized for it. Then there is no restriction on number of pages you can add. Performance is the same, meaning they have unlimited scalability. Last, they can provide more website insights. For example, Google Analytics can create reports for each page. But the cons. They have a slower overall performance because they fetch each page as a package of HTML and CSS and JS from the server as it's being navigated to. And next, since they reload on every navigation, it can be hard to add real-time interactivity. And they can be hard to maintain because each page needs to be maintained separately. Then we have the single-page application, or SPA, also known as client-side rendering. A SPA will typically be an app of Create React App, or Vite, Angular, Vue, etc. This has been the most common way to build an application for many years. In a SPA, the bundle.js file includes everything needed to build the app. And the entire HTML is created on the client when the user opens the browser on the app's URL. So the page is blank until the JavaScript is downloaded, parsed, and executed. Then the framework, like React, will start building it inside the root div, and then finally load the data. And after it's loaded, only data in JSON format is needed to update the UI. The use cases for a single page application can be any web app that needs to be highly interactive. So what are the pros of using a SPA? First, they're fast, there's no lag, they've got smooth transitions and instant information present. This is because everything is loaded initially and not re-requested per page as with an MPA. Second, they're easy to debug because everything can be logged in the browser because it's browser only, such as data, page elements, and network operations. And third, since everything is downloaded initially, they can work offline afterwards, cache data, and then update when possible. But there are some significant cons. Most importantly, they have a slow initial load, which is increased with everything that is added to the bundle, such as libraries. And meanwhile, the user is just looking at a blank screen and then afterwards a bunch of loading spinners. Next, search engines like Google cannot know what's on the page because the crawlers read strings, which like HTML. So typically your SPA won't show up in the Google search results unless you optimize it in certain ways. And they also need JavaScript to function and therefore cannot be progressively enhanced and run poorly on devices with a low processing power. And finally, they cannot hide information from the client because the data only exists there, meaning things such as API keys cannot be stored in a SPA. For that, they would need a backend or a serverless function. So the key difference between a SPA and an SPA and an MPA: in a SPA, everything loads initially and only data in JSON format is requested for making updates, whereas in an MPA, the entire page reloads per request. Do I have water here? No. Oh, yeah. I think I'll be OK for now. So this brings us to SSR, which combines the advantages of an MPA and an SPA. Instead of generating the entire application on the client from the JavaScript bundle, server-side rendering means that you pre-render in the initial pages on the server and then send them on demand. So this lets the user go to a URL and instantly see a fully formed page with components, and they can start reading the content immediately without waiting for React to build the page. And then the JavaScript bundle required to interact with the page is sent alongside the HTML. In relation to SSR, we also have something called static site generation, or SSG, which lets us pre-render pages in the build process of the app and then upload them to a storage bucket. The result of SSG is the same as with a quick and simple static website rendering, but we can generate the pages from, for example, React code. Our problem with SSG is that the build time scales linearly with the number of pages. So if you have a lot of pages, you could be waiting a long time for your app to build. Also, you have to rebuild and redeploy whenever data changes. Server-side rendering is implemented in so-called meta frameworks, which are frameworks around other JavaScript frameworks, such as Remix and Next for React, SvelteKit for Svelte, and Nuxt for Vue. So these frameworks are full-stack implementations of a web app, meaning they have their own server with things happening. And they support both SSR and SSG and can decide when to use what. So for example, if an app has a couple of pages, which of one of them has data that is changing, in the build process, all the static pages are rendered, and then when the user opens the app, only the page that has dynamic data will be rendered at request time. These meta frameworks also typically include things like file-based routing, APIs to handle data fetching on the server, caching capabilities, image optimization features. So let's get back to that JavaScript that is sent along with the pre-rendered pages in SSR. We still need JavaScript to run on the client to handle any interactivity. So instead of conjuring all the DOM nodes from scratch, the framework, like React, will adopt the existing HTML. And this process is known as hydration. The framework will attach the event handlers and, for example, fire effects and add state. And then afterwards, the page is fully interactive. However, it essentially has to rebuild the entire tree and compare it with the existing one to know what to hydrate. So this quote by React core team member Dan Abramov explains it well. Hydration is like watering the dry HTML with the water of interactivity and event handlers. So there you have SSR in a nutshell, done by modern frameworks like Next.js. It lets you load the initial page quickly, yet still have an interactive SPA. So this sounds great, but SSR isn't perfect. First, after the initial fetch of the HTML, the browser will download the JS code, parse it, and then execute it. So this causes the fully rendered HTML, the pre-rendered HTML, to look fully interactive, but in fact, it doesn't contain any JavaScript yet. So the user is stuck in a place often referenced as uncanny valley, where they will click a button, but nothing happens. And the time until they can interact with the page might even be longer than it would have been for a plain SPA version of the app. So why does this happen? Firstly, you have to fetch everything before you can show anything. All the HTML with the data fetch must be processed on the server before it can be sent to the client. Second, you have to load everything before you can hydrate anything. That's because React needs to match the tree in the browser with the one from the server. Third, you have to hydrate everything before you can interact with anything. React will start the hydration and then not stop until it's done. So there are many strategies in different frameworks trying to solve the hydration problem. Partial hydration can be used to define that only certain components need to have JS attached to them. For example, in Astra, you can define which components to hydrate with the directive client load. And we will also see this in React Server Components later. With progressive hydration, you can lazily load components JavaScript, for example, with Astra's client visible, or with React suspense. Selective hydration lets you prioritize which components to make interactive first based on user interaction. And this can also be done with suspense. And there are other ways being done in other frameworks, such as with resumability and Quick. Let's also mention the concept of streaming. It's a part of the Fetch API of ES6. It's available in React 18 and is a big part of React Server Components performance. Streaming allows you to break down a request into smaller chunks and progressively send those from the server to the client, and then render each chunk as it's streamed in. And we can use it to send components down to the client as soon as they've been generated. So finally, with all that knowledge, we can move to React Server Components and how they solve the problems that we've been seeing. What if we could decide when we need the behavior of a SPA or an MPA all in the same stack? I'm going to be using some simplified versions of the code that will be in my demo later here in this section. So what are they? React Server Components are components that run exclusively on the server. Server components never re-render. They run once on the server to generate the UI. And their JavaScript is never sent to the client. And when I say rendered on the server, I mean the server that is the part of the full stack framework like Next.js or during the build process of the app, not some backend REST API. This is the frontend's own backend, which in many cases eliminate the need for writing a REST API. Server components differ from server-side rendering because they are never hydrated, meaning the resulting app is partially hydrated. And then hydration to non-RSC components can happen concurrently with RSC streaming in, since the compute load is shared between the client and the server. And since RSCs are run exclusively on the server, we can write database queries right inside our components. So here's an example of a simple server component called JokesList. I can query my database through an ORM like Prisma and have the data available and the component fully rendered before it's sent to the client. Server components introduce async components, basically an async function, that can asynchronously fetch data on the server without causing any issues for the client side. And you can do any kind of data fetching in here, such as calling your API. Because server components only render on the server, this means that a big chunk of React's API is incompatible with them. For example, we can't use state because state can change, but server components can't re-render. And we can't use effects because effects only run after the render on the client, and server components never make it to the client. We also can't use any browser-specific APIs because they don't exist there, such as window location. And we can't use onClick and onChange because they require client-side JavaScript. So server components themselves are simple, but the React server component world is more complex. We still want to have interactive components that include effects and state and event handlers. So, because of this distinction, there are now two types of React components: server components and client components. Client components are the normal React components that you can do whatever you used to inside. Note that they are still pre-rendered on the server during the build and then hydrated on the client, as with the pre-existing SSR. However, client components must be marked with use client. That allows us to use things like state and effects and onClick as normal. Excuse me, I'm going to get my water now. Yes. So here's an explanation from the Next.js app router docs on the limitations in server and client components. If you need to fetch data, access backend resources, keep sensitive data on the server, or keep large dependencies on the server, use a server component. If you need to add interactivity like onClick or onChange, or use state or effects, or use the browser-only APIs, use a client component. How do React server components work? What happens is that React renders server components into a special format called the RC payload. It is a streamable format that represents the DOM, like a serialized version of a React tree. The RC payload contains the rendered server components with holes of references to client components and the props they pass down to them. It is used both to generate the pre-rendered HTML on the server and to update the DOM on the client without a need for JavaScript. So here's what it looks like in the console. We have the initial server-side rendered HTML of the page, as well as the RC payloads, identifiable by the _RC name, and multiple client-side JS bundles. So these are used together to build the interactive page. And since this jokes component is defined as server only, it doesn't need to be hydrated at all, and its JavaScript is never sent to the client. And as with everything, it's a bit complex when you start digging, so let's just leave it at that for now. When an RC needs to be re-rendered due to data change, it can refresh on the server and then seamlessly merge into the existing DOM without a hard refresh, updating only the parts that have changed. As a result, the client state is preserved even as parts of the view are updated from the server. And this is possible because the RC payload only contains references to client components and can leave them untouched. So what are the benefits of using React Server components? Firstly, data fetching. Data fetching can happen in components before they are sent to the client and will be faster since they can call the API or database in proximity to the resource. And inside RC, you have access to all your backend resources. Next, they can increase security by keeping sensitive data and logic like API keys on the server and never risk exposing them. And then caching. By rendering on the server, the result can be cached and reused on subsequent requests and across users. And bundle size. Server components allow you to keep large dependencies on the server, meaning you can exclude all that JS for those components from the bundle without restricting your use of them. For example, a library like Lodash, which overall will lead to a more performant application. Server components can furthermore be streamed, meaning they can be sent in chunks and viewed as they become ready. Therefore, they integrate naturally with React 18 Suspense. Finally, developer experience. There's a lot less hassle on the client with effects and keeping data in the state. Just fetch it async off the client. RC, however, comes with some drawbacks. Firstly, they require a framework. In practice, you will only be using them in frameworks like Next.js, which is per now the most reasonable way to use them. You become bound to the Next.js way of things. Second, they create increased complexity. As a web dev, you now need to understand a lot more concepts than before when you were just making a spot with Create React App, such as what you can and can't do on the server. Next, it can be hard to onboard new developers because the learning curve is a lot steeper when aiming to write quality apps. And finally, it's still relatively new and not everything has been figured out, such as testing and compatibility with other libraries. You risk having to refactor things or write specific workarounds. For example, Material UI didn't become compatible until last July, which was like almost a year after the app router was released. There have also been a lot of bugs since it was released, but it seems to finally be settling down now. So how can you get started? So the most reasonable way is Next.js app router. It's available from version 13.4 and onwards. So Next.js is made by Vercel and battle-tested and enterprise-ready. React Server components are part of React 19, but developed closely with Vercel and Next.js, which is really good for building apps with them because everything is optimized and working smoothly. And of course, having the entire React ecosystem follow. So to make a Next.js 14 app, run this npx create command and define whether you want TypeScript and Tailwind and such. And you will need the app router option set to yes to use RC. And it's worth noting that not all CSS will work with RC. For example, the CSS that is loaded on the client. So for example, Tailwind is a really good alternative. And then Material UI is making a new library to specifically work with React Server components. CSS, that is. So when you run this command, you will get the boilerplate for the Next.js app, and you can start using RC. There's not that many files to confuse you. It's mostly standard files such as package.json and tsconfig. What matters here is everything inside the app directory. So in the app router, you will be coding server first, meaning everything you do is a server component unless specified otherwise, which means that this layout and page file are server components by default. I'm not going to talk so much about the old Next.js pages router, but basically you don't have to use anything like get server star props, since pages are server-side by default, and you can just fetch data in your components. So it's a lot more straightforward. In the app router, you define routes by making folders containing a page.tsx. This makes it a valid route. I have some routes here, /jokes and /new, and then /jokeid subroute, which is a dynamic route, meaning it's parameterized. Then you can also use files with reserved names such as notfoundtsx, errortsx, which are error boundaries that will render inside the layout of the route, as well as loading.tsx, which creates a suspense boundary around the page. And all of these can be granularized, so you can add them to the root or to subroutes or wherever you want. You can also define API routes in here, like in the pages router. The route.ts file is a reserved name and will allow you to create API endpoints. Then there is support for SEO with, for example, meta tags. They can be added to any page or layout and can be generated dynamically, for example, using wrap-params. And with Next.js comes lots of optimizations, such as caching. If you deploy on Vercel, all the pages generated will be hosted cached on Vercel CDN, if you use Vercel. And they will optimize your images and can preload links on hover and such. So how do we use React Server components in Next.js the right way? What are the best practices and development patterns to get the most out of them? The best practice is going to be to move your client code to the leaves of the component tree. In this way, you ensure you do not ship unnecessary JavaScript to the client. React will then hydrate only these client leaves, as we know as partial hydration. You could, in theory, just put use client on your root and then code however you want, but that just means that all your components will have their JS shipped and pretty much takes you back to server-side rendering. But please, don't be afraid of using client components. It's normal to have bigger client sections where there are parts of the app that are very interactive. So to use a client component in a server component, you simply import it. So here, the delete functionality has been extracted to a component, which is useClient because it needs an on-click event handler. However, when going the other way around, you cannot do the same, without turning the server component into a client component. You instead need to slot them as props, and they will fit as separate chunks into the client tree. The client component here does not know what is being passed down, and this can be referenced as the donut pattern. This means that our tree can look like anything we want, and we can add client-side logic in the parent components as well. So here, only the green components are hydrated and contain JS, and the rest is just HTML. With this pattern, we can furthermore implement things like state management. By providing a wrapper client component with state, for example, using React context, which only works on the client side, we can use this state in the leaves without converting the server components in between. For example, we can make an error message provider or a theme provider. So when combined, this allows us to make apps that are extremely performant due to their large amount of non-hydrated content while still being fully interactive. You could have a donut pattern collapsible sidebar, a theme toggle provider, search and buttons on the client side, and then you can share your state between your components however you want. So when building an RC component tree, there will be some limitations between client and server components. For example, since the client component exists on the client and the server component on the server, props need to be serializable. That means that you cannot pass functions through the server boundary. Instead, we must create API endpoints to communicate between them, or React server actions, which makes it a lot easier. So I'm going to talk about that later. So how do we manage data with RC and the app router? I already showed you that you can make database queries through an ORM like Prisma. And you can, of course, use the fetch API. And there are a bunch of parameters you can add here, such as cache duration, tags for validation, and such. And you could potentially be getting a cookie, making an authenticator request to an API. And getting your data this way in server components is very efficient because on the server you have this privileged environment with everything you need accessible. If you use the same data in multiple components in a tree, you do not have to fetch it in the root and pass it down. You can fetch it in each component where it's required because it's automatically memoized. You can compare this pattern to React query or TanStack query, where you will call your hooks wherever they are needed, and then they will all call the same cache data. Plus, you can pass it down to client components when you need it, for example, as the options of an autocomplete component. So what about data mutation? I mentioned that you can create API endpoints like in the Pages router, but let's skip that for now and look at something way better called server actions. So they just became stable with the release of Next 14 and are also a part of React 19, which is probably going to come at probably within this year. And they are the preferred way to mutate data. They kind of complete the whole React server component story. So it's simple. You mark a function or a file with useServer, and then Next.js will make a hidden API endpoint for you, allowing you to call it from anywhere, like from a client component, which solves the problem of passing functions between the server and the client. And in addition, it gives you type safety between the server and the client through RPC. So here I have a file with useServer, turning the function inside it into a server action. I can now call it from a client component. And that's it. However, I also need to tell Next.js that I have changed something inside the data of the RSCs, and it needs to revalidate the view and fetch new data from the database. So I then call revalidate path at the top there with a relevant route. Looking at our data management graph, the server action seamlessly takes us back from the client to the server again. Server actions also integrate nicely with form submissions. So here I have a form and a function marked with useServer. And when submitting the form with the action property, it can, without JavaScript, call the server action and then add a joke to the database. And again, I have to tell Next.js to revalidate the view. So here's an example of something I made for my current consultancy project where we use RC. So in this example, there's a client component collapsible container with an RC fetching the message data and then mapping to RC message components, and then an interactive client component input field for submitting with server actions, taking us back to the server, and then finally a client component wrapper to handle automatic scrolling. So there you have it. React Server components in the app router allow you to do whatever you need to do, whether it's MPA stuff or SPA stuff, or include SSR or SEO or any kind of functionality you need, all in the same stack. So it's quite amazing. But React Server components definitely bring a new mental model and architecture. So let's get into a demo of the Joke app. It's actually a remake of a tutorial from the Remix documentation, but of course very different because it uses RC and Tailwind and server actions. And it's containing quite simple implementations. Let's see. But now I need to duplicate this again. Okay. Can you see this? Yep. Okay. So this is the app that we're going to be looking at. It's pretty simple. You can read jokes and get random jokes and click on specific ones. Is this big enough, by the way? Yep. And add your own. For example, arrays. Why was the developer unhappy with their job? They wanted arrays. So now we got that added. And then you can also delete it. And it's deleting. So this is using a real database here. So that's why we see that it's, not super fast. So let's look at the code. And I'm just going to jump to my local here. Yeah, so there's a bunch of folders here, and then the boilerplate files that I showed before. Validations for forms, utils, Prisma stuff, lib, which is my data access layer with functions for fetching data and actions, server actions, components, and then the app router. So let's head over to this jokes route here. And there's a header, there's a footer, they're just links, and this is all server components because there's no interactivity required here, which means there's never going to be any of this is never going to be created in JS on the client. And then there's a sidebar, which is actually this list here. And it is also a server component, but it has a random joke button, which is now a client component because it is using some hook that requires client-side JS. So this is now its own component, which has its JS shipped. But that's it for this sidebar part here. Yeah. Then we have the new, the page as well. That's just displaying the current random joke. Then the new page. So that's this page here. Jokes new. Hold on. I think it's like a little bit weird, this position here. Yeah, that's okay. So in this component, I have a form with the action property, which is bound to a server action. So this action property binding to server action like this is actually a part of React 19, which is extending the form component, letting you bind it to a server action and then automatically have a post endpoint to this created. So this is a server action with userver, and it's getting a form data object because when you use the action property, and this is just web standard, by the way, it will get all the fields inside the form as a form data object with its values. So we can get the values of the field like this, of the form, and then add it to the database and revalidate the path so that we can get new RC rendered. So when I do this, it's going to add to the database. Yep, it's super quick. And then revalidate the view and get a new server component back. And then, I don't know if you noticed, but when I add this, it should be not super fast. Let's see. Adding. So you saw that adding there. So if our database, if the trip to the database of DAC is slow, we would want to just display some feedback there so that the user know that they clicked the button. So there's a submit button, and this is a client component because it's going to display some interactive feedback. And this hook is also a part of React 19. It's called use form status, and it will return to us the state of the form that is currently submitting. Yeah. So that's how we get this feedback here. Then the route for the joke. So this page is getting a joke, this one, from the database based on the params of the page here. I'm going to show you the right one here. And it will then query from Prisma based on the joke ID. And then we can display this and also include a delete joke button. And this is also a client component because it's showing us this deleting feedback. And here I'm using an API called start transition, which is a part of React 18, but can now be async with React 19. Meaning, first of all, what it does is it marks something as non-urgent so that your app will be responsive when something less important is happening. So we have this async server action, which is deleting from the database. And we wrap it with a transition and get the pending state of that while it's happening. Yeah, that's pretty much it for the demo of the main functionality. But I also have additional routes here to display some RC concepts and typical things that you might encounter when using React Server components. So first of all, nesting components. So I mentioned that you can put server components inside client components if you slot them as props. So here you have server component, client component, you need some interactivity, but you don't want to make this into a client component. So then when you slot it as a prop like this, sorry, this one, it's the children prop of the client component. It can be referenced by the component as just whatever it is. It doesn't really know that it's not, that is a server component because it's just passing a reference. So then we have server component, and I can show you that this is indeed, so inner server, outer server, only rendered, printed on the server, whereas the client component is only printed on the client. Yeah. Then revalidation. So I mentioned that when you update an RC, it can leave client state, it maintains the client states. So this is just to show you that that works. So let's just add some state here. And then this is React Server component list. And then add something. And it will maintain the state here and not break anything, even though you just fetched new data from the backend. Global state. So I was talking about making state management with a provider. For example, like this, you have a provider with React context. Let's see, this page here. Provider, and then server components. So imagine you have a bigger tree where you have server components across the tree, and you don't want to break or make them into client components. You can use a provider and then have a set theme component, for example, which is client, which is using the theme to set it. And then some other part of your tree have a use theme component, or whatever you need to use, which is also client, which can then use the theme and display some change based on that. Next up, there's a lot of, you could say, innovation happening with forms now with React Server Components and React 19. So let's just look at a server-validated form. Server form. So this is now calling a server action, which is validating the data from the form data with, for example, a library like Zod to check that the types are indeed what you expect them to be. And then when it doesn't validate, when it fails, it will just say server error here and then return. So that's something you should be doing when you're passing data from the client because you don't know really what's being sent there. But then you can also validate on the client. And also using Zod here, but when I parse this with Zod, it will fail on the client. Client error. So that's where we're doing the validation now. And you can combine this to use, for example, React Hook Form with server actions. And this also is using an optimistic update, which is a new hook from React 19. So what's going to happen? Actually, I'm just going to show you this first. So we have the React Hook Form validation here. And then, you know, when it's valid, the button will be clickable. But what I've done is on the server, I have one more character requirement so that you can see the optimistic update and the rollback. So when you add it, it's going to optimistically update and then roll back because on the server, it checked the data properly and it wasn't valid, you know? Yeah. And then when you add it, it's optimistic, instant, nothing needed there. So you can use this to make like really interactive forms. But there's also a new way to write forms now, which is the use action state hook, which is also coming to React 19. And what's special about this is it can work without JavaScript. So it's using a use action state hook to get the last state from the server, from a server action. So this server action is returning, for example, success true or errors. And when we submit it, it will have the last state from this hook, and you can use it to display something, but this will still work without JavaScript, meaning it's progressively enhanced. So when this fails, it will give me the validation back here from the server. And then when it's valid, it can submit. And then turnoff.js still works because it's just a post endpoint being called here. Yeah. And then suspense. So this is a pretty important part of Next.js 14 because every time you're awaiting some data, you need to display something while it's happening. So in this example, I have a bunch of await new promises. So this main component, which is the main page, is being blocked, and I'm displaying a loading.tsx fallback for the page, which is like an implicit suspense boundary. And then let's say this header needs some data, it's also slow, and then this component has a slow database call, whatever. So then each piece is kind of has its own suspense with its own fallback so that you can always display as much as possible. And you can like use skeletons, whatever, make this nice. Yeah, and then when it's loading, I can still click this button while it's still fetching data from the server. React Query, you can also use React Query. Typically, you don't need to because you can just await. But if you're, the typical case for this would be authenticated time-based fetching. So if you have like dashboards, you will want to get, this is also doing that actually, like every 5 to 6 seconds. You can use React Query to keep fetching data. But that's more like not your default, I would say. And then finally, a bit more on transitions. So you can also use, hold on, transitions to send server actions based on some event. It doesn't have to be a form action. So for example, on blur. So I'm just going to edit this here, and then it saves on blur. So then you can bind form to an on blur, and then send a server action and get the pending state of that. Yeah, I think that's it for the demo. So let's see if I can fix my slides again. Yeah, good. We're good. Yep. So that's the Lighthouse score of this app. Unoptimized, I just follow the patterns that I've been mentioning. And this is a small app, but you get the point here. And all in all, you can build really performant apps by default, where the limitations of RC will make your code better, unlike in plain React, where you're just going to do whatever you want. And it creates a badge from the metadata generation dynamic based on which joke has been selected. And finally, I have real-world experience with RCs because I'm building a medium-scale app production app with it. So let me mention my requirements and my experience with this. I'm working on a project set to last at least 1 year, and it's a rewrite of an existing MVC app with a lot of technical debt. And I was lucky enough to be given the responsibility of picking the technology for the front end of the new solution. So the app will contain interactive dashboards, complex forms, articles through a CMS, and a lot of static data, and a need for SEO. It also needs to be mobile-friendly, accessible, support multiple languages. And a big part of the app, and something I made sure to proof of concept with RC before choosing Next.js as my framework, was the customer's own design system library. And this app is a great case for RC because it can server-side render a lot of content, but then also be highly interactive where it needs to be. And I'm finding it to work well so far. However, I've had to do quite a bit of trial and error to build things that isn't really standard functionality in the docs. For example, I had to create wrapper components for the customer-specific library to be able to use them in my project and put server components inside them. I also had to pick my I18N library without much guidance from Next.js. And it's working well, but there were complexities in the beginning. And finally, testing RC, specifically component testing, is not really covered anywhere. And to test async components with React Testing Library, there's currently a need for a workaround. But all in all, it's going really well. The app is performant, it fulfills the requirements, maintainable, enforces best practices, and the developer experience is great. So Next.js App Router with RCs inside provides so many tools to let me focus on building my app. To finish this off, what is going to be the future of RC? There is no doubt that this is the way React is going now. It's not just some hype cycle that is going to die out, it's the result of many years of work from the React team. And it's likely that other frameworks or more and more frameworks will implement their own versions of RCs, such as Remix, who have announced that they're working on it. And there are so many solutions being proposed to improve the performance of web apps with the goal of finding the optimal balance between UX and DX. And this is React's take on that. Nonetheless, there's a lot of things to be figured out as React Server components are battle tested. So here's the repo for the joke app. Everything is there, as well as the reference demo pages. I really hope that when you encounter something that's there, it can be useful to you. And here's some more resources that I used during my RSC learning experience. The Vercel docs are really good. Just remember to use the app router version. If you click on something, don't use the old version. And they have some template apps, and they also released a Learn Next.js course, where you build a dashboard app from scratch and then deploy it to Vercel, which is good. And for YouTube, ByteGrad does a lot of thorough RSC content, and Code with Antonio does these really incredible clones of apps like Twitch and Miro with full YouTube code-alongs. And just before when I was like revising my talk here, I realized he had made the code paid. So there's only videos now, but they're still good. Yeah. So thanks for listening. I hope you're really excited for this as well. And I have a blog where I post about RC, testing, integrating with React Forms, and more. So thank you.